to another Mr. Betabyte video, and this one's a little bit different insofar as we're taking another look at the PCM F1. Now, I did do a video on this a couple of weeks ago, and we got it to power from the mains power supply, the AC 700, but it's still not right. It isn't doing what it's supposed to do. So, demonstration of that. It has a battery in at the moment, so you can see there, we've got the emphasis and the mute light on. If I power it on, it stays the same. If I power it off, it switches over to the battery, but it's exactly the same. Now, record mute, pressing that, I can hear the relay going. So there's power to that side of the board, and this will all make sense as I go through the video. If I power it on, hear the relays click. Now sometimes I can hear the mute relay come off or click, basically releasing the mute, but nothing changes on the front. So I've still got some sort of weird power issues going on with this. I'm hoping that that Schmidt trigger chip is actually good, and I will check that to make sure that the inputs and outputs are doing what they're supposed to do. It's mainly the outputs, of course, because I know the inputs are probably good. Going through the circuit in the first video, we pretty much ascertained that that chip was bad, but it's not inconceivable that the replacement chip is also bad. I mean, it's old stock, so you know, anything's possible. So without further ado, let's crack on. So I've done a bit more testing, and haven't really found anything obvious. The chips on the power supply board all seem to be given the right values. Everything seems to check out okay, but I do have a voltage problem, power supply issue, and I'm suspecting this. Now, this is a DC-DC power supply unit, 916 in, and then we've got 5 volts and plus minus, and 15 volts plus minus, and that would make sense that that is possibly not the best. When I was testing it, I was finding that occasionally it would actually power up briefly, and I'd get the patterning on the screen that you expect from a PCM device, and it would just sort of fade out, almost like the power supply would just shut down. Now, looking at the circuit diagram, we have a lot of capacitors in this, and some I know are quite prone to fail. These 6.3 volt ones are all suspect, but personally, being the type of kit it is, I'm going to want to change all of these capacitors, which I probably don't have, so that'll be fun. Yeah, so I need to get this out. As you can see, I've unscrewed it just to assess how far I can actually get this out without having to pull out connectors. And the good news is I don't have to put out connectors. The bad news is I don't have to put out connectors because most of them are soldered, and you would half expect that. You need reliable connections. It is a pain. This orange one is on a connector that's loose. The black one, I believe, goes to one of them. Screwed chassis. The blue and the red are red is plus 15, blue is minus 15. and they're soldered to the power supply board on the other side of this. So it's a bit involved to get this out, to be fair. This is fine. It's just unplugs from, where does it unplug? From here. So that's easy. And the orange plug on the other side of the board is a similar style of connector. A bit unusual for Sony to see these. So, when consumer electronics anyway, beaters. So, yeah, I suppose better crack on and get this unsoldered and get it out. And I'm just going to blanket change the caps, to be honest. It's worth it. And just breathe some more life into it. I mean, even if it's not at fault, it's done. It's not a bad thing. These power supplies, or this style of power supply, are always dodgy, so it's worth doing. I've changed my mind on the changing the capacitors on this. I've actually ended up lifting out every single capacitor and checking it on my capacitor tester, my multi-tester. And although you can't 100% trust these, I mean, they do give a good indication. Every single capacitor in there is perfect. It's just, it couldn't get any better. Probably new ones wouldn't be as good as that, unless obviously you get these high quality ones, high quality replacements. But yeah, I'm more than happy just to put this back together, to be honest. And I can't find anything wrong with this. When I put it on the test power supply, output voltages were all a little bit low, but then there was no load, so I would expect sort of that, possibly. So yeah, I'm going to put it back together, we'll do some voltage checks, and we'll take it from there. Lots gone on with the PCM F1 since the last segment. I've changed quite a few chips on the logic board, system control, but I was still getting crazy high voltages from the power supply. So I've taken it back out, and it turns out, I mean, I went through the circuit diagram, and the only thing I could really think it was is this Zener diode. And that actually is down here, and basically what it does is it straps the control voltage for the chip to then generate the correct amount of oscillation, then to then generate the right voltage for the outputs. It's fairly simple, I suppose, switch mode power supply type arrangement, oscillating power supply. And it's odd. I sort of, because it's a Sony, I really didn't expect it to be that simple. And testing that diode, it's fine. On the tester, it's fine. But it's obviously, relative to load, it is changing its characteristics. So the more load that's on it, the higher it's actually pushing up, and the more voltage is actually coming out of the circuit. And that's more noticeable on the 15 and minus 15 volt rails, but also there on the 5 volt and the minus 5 volt rails as well. So changing that, testing it, I've got a solid 15 volts, minus 15 volts all the time, regardless of load, which is great. Before I was getting 9 volts with no load, 18 volts at 0.5 amps. So yeah, hopefully that's done it. But I just think it's crazy that one Zener diode can cause so much damage throughout this machine. And of course, left unchecked, it will keep just damaging the chips. You can change them for ever, and it will just keep blowing them. But of course, the telltale is that the VU meters don't work. And I actually picked that up from the fact that I put the battery in to check it. The battery had gone a bit flat, and everything worked. albeit not very well, because obviously the voltage was so low. But the actual VU meters worked, and yeah, it was great. And that made me think there's got to be a power supply issue. So yeah, I found it. So yeah, pleased with that.
Thousands of tears later.
So I have quite a few more grey hairs, having spent so much time on this this PCM F1. And the final part, and I'm doing this in reverse order. The final part has actually been removing the two relays. RY602 is for the power on off, and RY601, I think I've got this the right way around, is for the AC-DC swap over, so battery or the mains power supply. And both relays were weak. I was getting odd issues where they wouldn't always lock, and they are actually quite odd relays. They are actually magnetic switches. So rather than it being a true relay, so you energize it, switch it on, energize it, switch it off, what these do is a brief current is put through one coil, and it switches it one way, and then a brief voltage is applied on the other coil, and that switches it the other way. So it's literally a magnetic switch. Which is, again, another Sony thing, because, of course, you don't get any EMF being emitted from the relays. So it really is totally tuned to be a noise-free environment on the analog side. And the other thing as well, while I'm in here, the DC-DC power supply, that ended up being a total loss. It did sort of work quite well. The 15 volts was sort of 15.5 volts minus 15.5 volts ish, but the 5 volts was really high still. And after doing a lot of checking, and I changed a couple of capacitors, and see there's a couple of missing there because I replaced the 2 on the plus minus with single ones making up the same value. I actually came to the conclusion, and it did take a very long time to come to it, that I've probably got a short on the transformer, and it's causing false feedback back to the chip. I changed the chip as well. So I was getting really strange results from the feedback circuits, but the feedback circuit is derived from a winding on here, and it was just really odd. So I gave up in the end. I just thought I just can't go any further with it. It's taking a lot of time as well, and I came to the conclusion that this was probably leaky, given what was going on with the circuits. So to be fair, I can't actually remember, because it's quite a long time ago. I say it's quite a long time ago because what I actually did with this, I managed to source some XP power units, and these units are they're fully encapsulated power supplies, and they're modular based, really great units. The actual regulation is absolutely spot on. The downside with them is that they do not like capacitive load. Now that's fine because there's plenty of smoothing before it. The regulation is absolutely excellent, but it does mean that I've had to remove all the capacitors, or majority of the capacitors on the especially on the 15 volt lines, to get this to work. If you leave them in, it will just keep tripping out. It overloads and then it comes back, overloads, comes back, because it's trying to charge those capacitors. It doesn't like capacitive load. But there's no ripple, there's no noise. It works really well. So I'm very, very pleased with that. On the top side, I ended up replacing quite a few more chips, including one chip. It was Schmidt trigger. I think it was TC4027BP that was actually getting really hot and causing all sorts of problems. When I changed that, I actually started getting good results, and I'll show you what I did on the top. So what I'm going to do now is put this back together. I have actually already tested it. It does work. The only thing that doesn't work is the power on off. Insofar as if you do press the power on off, it does put the VU meters off, but it doesn't actually turn the unit off, which I suppose you'd sort of expect. Yeah, let's get this back together. And I will say I didn't record an awful lot of the process. It was just too much. And I was doing little bits when I had like 5 or 10 minutes here and there, and it just didn't happen. So yeah, this is sort of a little bit of just a show and tell at this stage. But slide the board under. And this does not sit too well. I know I've got quite a lot of cables crammed under there, but it's never sat well. The board is actually slightly warped, and that's how it came to me. It's just slightly warped around here. So even though I've pushed those cables down, it's still going to look as if they're stressing things. So yeah, I'll put this back together on the bottom side, and we'll have a look at the top. Okay, so the top board, I'll just remove the top power section, and get that out of the way. So a lot of the logic control and basically things to do with the meters and the on-off, power on-off, charging, that is all decided by all of these chips here. This is the 15 volts regulation side of things. So what I've done is horrible. I'm not proud of this. I've just cut the legs of the caps and made sure they're well out of the way. These are glued, well and truly glued. But I didn't want to take them out because in the future, who knows, maybe we'll put an original power supply back in there, DC-DC power supply, and all will be good. I was still getting problems with it trying to cut out under certain circumstances. It would occasionally just sort of try and shut down. So I actually had to cut the legs of these two capacitors as well. So we've got just these two, offering some additional smoothing if needed, but it isn't needed. It really isn't needed. Those XP units are great. 5 volt wise, minus 5 volts goes underneath the board. Should have showed you that, but it's on a grey lead. Positive 5 volts. Now what I did find is because the negative 5 volt draw is much lower than the positive 5 volts, the positive 5 volt was being pushed up. I think that's a bit of a strange thing with the XP unit, that it sort of expects fairly standard current draw on the negative and the positive side. So what I've done is I put an inline, again this is not the way I'd like to do it, but I put an inline diode in here just to drop it down somewhat down to 5 volts. So and that works well. So yeah, that's quite an interesting way of doing it, I suppose. But some of these chips are actually really sensitive to over voltage, and I mean the Schmidt trigger is one case in point. But yeah, so pretty much I have changed this chip, this chip, this chip, this one, this one. This one I was very dubious of. It's a Hitachi chip, but it's a Chinese copy, so I was a bit like, but it seems to work. That one I didn't, that one I did. So yeah, it ended up being quite a task. I also had a problem with 8 volts on a line that should be 0 volts. And I ended up removing a resistor to get around that. I just could not find why I was getting feedback on a certain line. So yeah, this is not my proudest moment, but I've got it working. So, and it's absolutely fine. I mean, I've checked it through with the meter. Nothing is now being loaded. Everything runs cool, or as cool as it should. And the only side effect really is if you press that power button, it will just turn off the level meters, but that's fine. To reset it, you just press the power button on there. So we do have a fully working PCM F1, finally. I mean, this has taken so long. One thing I forgot to mention was those XP power supply units. Because of the global situation as it is, I actually looked those up last July, and I was still battling with that power supply, and that's partly why I was battling with it, because I just thought I just have to get it going. But they actually came into stock last November, and managed to get one of each. And when I actually got them, there were only like 12 and 8, I think it was, left in stock. It was really crazy. They just suddenly went out of stock so quickly, unsurprisingly, I suppose. So I was very lucky. And those 2 XP units actually cost £78 for the 2. So not cheap, but they are good. Highly recommend them. So I suppose with that, let's get it back together and give it a test. So there we have it. It is working. Yay! It's really been such a journey, and working really well. And I've got the PCM-701ES as well, just on test. So basically this is looped from the copy jack into the input of the 701, and you can see it's working well, and you can hear it's got really good audio as well. Tracking. So I find the tracking on the PCM F1 is a little bit sus, maybe. So you can see it on the 701. Well, yeah, it sort of compares. It's not bad. And yeah, it's great. So let's plug into the 701. So that's working well as well. And yeah, we're all good to go. So obviously SLF1, and then we've got the TTF1, which is providing power and a nice clock display, I suppose. And the RF out from that, you can see what's actually coming through from the tape. So yeah, really pleased with that. I'm so glad I got that PCM F1 working. It really was looking like it was a basket case, and although it is very bodged and it's not my finest work by a long shot, I'm not happy with this machine as far as what I've had to do to it to get it to work. So I hope you like this video, and please like and subscribe as well. And yeah, see you in another video. Bye for now.